Okay, we're going to do the word problem 6.4. So the first one is a banner's being created for a bake sale. The length of the banner must be less than 200 centimeters. So the length must be less than 200. The perimeter must be 500 or less. So 500, so I have an equal sign or less. Okay, so that's the perimeter, but instead of perimeter, I'm actually going to write a formula for the perimeter. So I'm going to exchange this for 2 lengths plus 2 widths will be less than 500. Define your variables. So L equals length, W equals width. Define the restrictions. So we know that length can be a real number, right? You can have a length of 5.2, but it does have to be greater than 0 because you can't have a 0 length, and you also can't have a negative length, and same with width. Graph it and find a solution. Okay, so I'm going to put this as my width and this is my length. So let's go up 25s, so 50, 100, 150, 200, 250, 51, 152, 250. Okay, now length has to be less than 200, so 200, that's the line 200, and you have to be below that line. And when I graph this line, I'm going to use the intercept method, so I'm going to cover this. So the length, intercept is 250, cover this, the W intercept is 250, and that is a solid line. Okay, and then we need to be less than that line, below that line. So we're in this zone right here. Okay, also remember that you can't be right on that line. So determine a possible solution. So your answers could vary. You could have 100 and 100. You could have 150 and for the width and 50 for the length. Okay, so it varies. We could go L equals 100, width equals 100. That's one possibility because it is in the zone. Okay, Sarah collects shells on the beach. She does not want any more than 300 shells altogether. She collects white shells and tan shells. She wants to have no more than 4 white shells for every tan shell. Write the system. Okay, so no more than 300, so all the white plus all the tan cannot be more than 300. She wants to have no more than 4 white shells for every tan shell. For every so I always try to kind of write it, and then let's say if you had 2 tan shells, then your white can't be more than 8. Does that make sense? If you had 1 tan shell, you couldn't have more than 4. Okay, defining your variables. So W equals white shells. T equals tan shells. The restrictions is that they have to be whole numbers. Okay, you can't have like a 2.5 shells graph. Okay, so I'm going to go, I usually make this my y so that it's like kind of like a y equals mx. So y, x, and let's go up by 50s again. 100, 200, 300. Okay, so the intercepts on this equation is 300 and 300. And then it would be a solid line less than it, so it will be below. And then when you graph this, you have to rise 4 for running 1. So since my scales are the same, 1, 2, 3, 4 over 1, and that is also solid. We're less than that line, so we're in this zone right here, but we need to be stippled. Okay, so determine a possible solution. You could have 100 tan and 50 white. Okay, anything that would work in that zone. Okay, next one. 4 teams are traveling to a tournament, cars and vans. Each team has no more than 3 coaches and 10 athletes. Each car takes 5, each van takes 8. No more than 5 vans and 11 cars are available. Okay, writing a system of inequalities. So let's just talk about people here. We have 4 teams, so that is 52 people. So let's just think that we can't have any more than 52 people. So 5 people for each car, 8 people for each minivan, and we don't want the people to be higher than 52. The cars can't be higher than 11. The minivans can't be higher than 5. So we have C for cars, M equals minivans. Restrictions, that they would be whole numbers. Graph this system. Okay, so I'm going to put C here, minivans there. Let's just say we're going to go up by 1s. So that's 5, 5 and 10. Okay, so covering up that, 52 divided by 5. So the C intercept is 10.4. And covering that up, 52 divided by 8 is 6.5. Okay, so we are below that line. Cars have to be less than 11 or equal to, so that's that line. And vans. Okay, so we're in this zone right here. Have to be less than all the lines. And don't forget that our solution would be stippled. Okay, write an objective function. So our objective function is that we're trying to figure out the number of vehicles to take. So vehicles equals cars plus minivans. What combination will require the maximum amount of vehicles? So the maximum amount of vehicles would be that you're going to take 10 cars. Okay, and that's fitting 52 people. Okay, because if we take 9 cars, for instance, that line doesn't even let us take, because 9 times 5 is 45, and then that would only have 7 extra people, and then we wouldn't have enough we wouldn't take a minivan. Okay, what combination will require the minimum amount of vehicles? So if we took 5 vans, because 5 times our 8 is 40. Okay, so how did I figure that out? Is that I kind of look for these intersections. I mean, obviously not the 0, 0 intersection, because that doesn't even really make sense. So those intersections, but that's an intersection that has a 10.4, so I'm just going to move it in to be the 10 here, and then that one is not a min or a max, it is in the middle. A vending machine sells juice and water. The machine holds at most 100 drinks. So the juice plus the water is at most 100. At most, 3 bottles of water are sold for each bottle of juice. So at most, 3 bottles of water are sold for each bottle of juice. Define your variables. So J equals juice, W equals water. What are your restrictions? They would both have to be whole numbers. Graphing the system. Okay, I'm going to make that 100 instead of 10. So we're just going to be going up by 10s. So that's a 50. And that's a 50. I'm going to put my J here and my W here because I like to do Y equals MX. Okay, so this has intercepts of 100 and 100. So a point there, solid line, we're going to be below it. This has a slope of 3, so 1, 2, 3 over 1. And it's also a solid line. We need to be below it. So here is our zone. And don't forget, we're going to be stippled in that zone. Okay. Objective function. So our objective function is our revenue this time. So each water, so 1W plus 125J, that is going to be what our revenue or our sales equal. So what's the maximum revenue? So the intersection points of the zones are here. Obviously the 0, 0 doesn't make sense. So we're going to try this point and this point. So this point right here is 100, 0. So 100 juice, 0 water. Okay, and this point here, we're going to have to figure it out. So where does this line intersect that line? So I'm just going to do it as an equal sign. So those are the 2 lines that we have. And this W equaling 3J, I can put it there. So 4J equals 100, so J equals 25. And then if J is 25, W is 75. Okay, so let's go 1 water. I'm going to plug in this point times 0. Or sorry, $1 times 0 waters plus $1.25 times 100 juices. So that's $125. And if we plug in this point, 1 water times 75 plus $1.25 times 25 juice. That's $106.25. So this is our max revenue, and that's how we could get it. Okay, Ed found spiders and crickets in the storage room. There's 20 or fewer spiders and 20 or more crickets. So spiders are 20 or fewer. Crickets are 20 or more. There are 45 or fewer crickets and spider altogether. So if you add them up, it's 45 or fewer. Okay, so there's our inequalities. We know that each one is an element of the whole numbers. Can't have partial spiders. Okay, we're gonna graph this. 1, 2, 3. So I went up by tens. Okay, I'm gonna put spiders here, crickets here. So this, using this line first, the intercepts is 45 and 45, a solid line. We're going to be less than it. To be spiders less than 20, so here's 20, we have to be less than it. Crickets are 20 or more to be above it. So here's our zone, and we're stippled in that zone. Okay, what combination of spiders or crickets would have the greatest number of legs, and what combination would have the least? Okay, so I'm going to figure out my 4 intersection points and my objective function. So my objective function is legs, which would be 8 times the spiders plus 6 times the crickets. Okay, so the points, this one would be 20, 20. This one would be 0 spiders, 20 crickets. This one up here would be 0, 45. And this one here would be the intersection of this line and this line. I do know that there's 20 spiders on that line. So if there's 20 spiders, there's 25 crickets. Okay, so I'm just going to plug in each point. So you could see here, I plugged in 0, 20, and here I plugged in 20, 20, 20, 25, and the point is 0, 45. So the amount of legs that each one would produce, so 0, 45 is 270, 280, 120, and 310. So you can see the largest, so that's part A, the greatest, and the least would be 120. Okay, next question. A Saskatchewan farmer is planting wheat and barley. He wants no more than 100 hectares altogether. So the first one I'm going to do is wheat plus barley is less than or equal to 1,000. The farmer wants at least 3 times as many hectares of wheat as barley. So wheat has to be at least 3 times the amount of barley. Okay, the yield per hectare of wheat is 50 bushels and the yield of barley is 38. And then each bushel pays out. Okay, so the revenue we're going to make, so for wheat, for each hectare, there's 50 bushels times each bushel is 525. So for each hectare of wheat, you're going to make that much money. Plus, for the barley, each hectare, produces 38 bushels, and then each of those bushels pays 361. Okay, so if we want to simplify it, each hectare wheat will pay out $262.50, and 137.18. Okay, so let's graph this. So this is 1,000. So I went up by hundreds, and then I'm going to use W as my Y because this statement, MX. Okay, so on this line, your intercepts are both 1,000, solid line. You're below that, and then this, we're going to go up 3 over 1. And we have to be greater than that. So we're in this zone. And you don't have to be whole numbers, so we can be, you can have 5.2 hectares. Okay, so we need to figure out these intersection points. So obviously I'm not going to use 0, 0. This one is 0, 1,000 right here, and then this one. So it's the intersection of these two lines. So down here, W plus B equals 1,000, W equals 3B. So I'm going to replace 3B with a W. So 4B is 1,000. So therefore B is 250. So if you plug B in for 250, this should be 750. Okay, so now we're going to plug both points in to see which one will maximize revenue. So the first one, if wheat was, let's go 750, and barley is 250. Or the next one, if wheat was 1,000 and barley was no acres. Okay, so 750, 250 will produce 231,170. And then the second one here would produce 262,500. So this one will maximize revenue. So don't plant any barley.